Look up at the night sky and you're seeing light that has traveled millions of years to reach your eyes. But what if you could see further? What if you could bring the universe closer? Today we're uncovering how telescopes magnify the cosmos. Welcome to Telescopes Uncovered. From backyard stargazing to space exploration, these incredible instruments have revolutionized our understanding of the universe. But how exactly do they work? Let's dive into the fascinating world of telescope optics and discover how they bring distant worlds into focus. Everything we see in space is light, and telescopes are essentially light collectors. The basic principle starts with a simple lens. When parallel light rays hit a curved lens, they bend and converge at a focal point. This distance is called the focal length. Magnification happens when we combine lenses with different focal lengths. But lenses aren't the only way to gather light. Curved mirrors can also focus light by reflection instead of refraction. Both methods achieve the same goal. The larger the light-gathering surface, the more light we collect. And more light means we can see fainter, more distant objects. This is why bigger telescopes can see deeper into space. The main lens or mirror is called the objective, and the eyepiece is where the magic of magnification happens. Together they create a system that makes distant objects appear larger and brighter. Now let's explore the different types of telescopes that use these principles. Refracting telescopes use lenses to bend light. Light enters through the objective lens and focuses at the back of the tube. These were the first telescopes ever built. Galileo used a simple refractor to discover Jupiter's moons in 1610. But lenses have a problem called chromatic aberration. Different colors of light focus at slightly different points, creating colored fringes. Reflecting telescopes solve this problem by using mirrors instead of lenses. Light hits the primary mirror at the bottom and reflects to a secondary mirror. The secondary mirror then directs the light to the eyepiece on the side. This design was invented by Isaac Newton. Other designs like the Cassegrain telescope fold the light path to create a more compact instrument. Most large modern telescopes are reflectors because mirrors can be made much larger than lenses. The eyepiece is where magnification is controlled. Shorter focal length eyepieces provide higher magnification, but higher magnification isn't always better. As magnification increases, the image gets dimmer, and the field of view gets smaller. That's why astronomers use different eyepieces for different objects. Not all telescopes collect visible light. Radio telescopes detect radio waves from space. These massive dishes can see through cosmic dust and reveal hidden structures. Space telescopes like Hubble avoid atmospheric interference entirely. The result is incredibly sharp images impossible to achieve from Earth's surface. Earth's atmosphere creates several challenges for telescopes. Atmospheric turbulence causes stars to twinkle and images to blur. This limits the resolution of ground-based telescopes. Light pollution from cities also washes out faint objects. That's why major observatories are built in remote, dark locations. Modern telescopes use adaptive optics to correct atmospheric distortion in real time. Hundreds of tiny actuators adjust the mirror shape thousands of times per second. The result is images nearly as sharp as those from space. Interferometry combines light from multiple telescopes. This creates the resolving power of a telescope as large as the distance between them. These techniques have revolutionized our ability to see fine details in space. From simple lenses to adaptive optics, telescopes have transformed our view of the universe. Whether you're using a small refractor in your backyard or the largest observatory on Earth, the principles of magnification remain the same. These incredible instruments continue to bring the cosmos closer, revealing secrets hidden in the depths of space. Thanks for joining us on this journey through telescope optics, and remember to keep looking up.